Okay, I think we can go ahead and get started. As I mentioned before, this is the eyesight stockpile volume calculations webinar. Today you're going to learn how stockpile volumes are calculated in Eyesight Studio. Your host is Clayton Fritz. Clayton is a technical consultant for the Eyesight team in the Denver Maptek office. He provides both training and consulting to clients throughout North America. Today's webinar will conclude with a question and answer session, so please feel free to write in questions in the panel on the right of your screen. I'll hand it over to Clayton now.
Thanks, Cherie. As Cherie mentioned, we're going to be going over how to get accurate volume calculations from stockpiles scanned using an Eyesight 8800 laser scanner. When the data is initially collected, it comes in looking pretty much like this, where there is no coordinate system assigned to the scans. I've colored them separately so you can see that there are three distinct scans that we use to get accurate coverage of this entire stockpile. The Eyesight 8800 scanner has a threaded point on top where we can attach a GPS to it and get a location where the scanner is itself, and that makes it incredibly easy to register these scans. To do that, we merely register them by a name, which associates these scans with the GPS point that we have in the survey coordinate system. We can now bring these scans in and look at them, and they're roughly registered in the right location. As you can see, one of these scans is not rotated in the right spot. The scanner location is correct, but it still needs to be rotated to the left. I left the back side out on purpose just so I can illustrate how easy correcting something like that can be. We rotate about the origin of the scan, since that is our known point, and then we merely rotate the data. We don't need to get it perfectly accurate, we just need to get it close, and then we will allow the software to take over from there. What we're going to do now is we're going to register these using global matching surface features. This is a unique algorithm to this to Eyesight Studio software, which allows the software to look at 5,000 random point pairs between all the data sets that are included in the registration, and it looks for matching point pairs along the same edge constraints and planar facets. And it really tightens up the registration by looking at more than just the site of the scanner and the backside itself. If you get this error, this just tells you that it's reached its limit, it found 5,000 point pairs, but it still sees room for improvement within the registration process. To fix that, we easily just click apply one more time and let the software run through this algorithm again. Now that the data is completely registered, we can filter it down so that we're only using the stockpile to be considered in our triangulation. To do this, there are several different methods. First, I like to roughly delete the areas outside of the stockpile. I'm going to do that by selecting the area that I want to keep and cropping everything outside of that. Now I'm going to come in here where this conveyor is and manually delete that out. It was extremely useful during the registration process, but is no longer needed. Just by highlighting the areas that we don't want and then hitting the delete button on the keyboard, that data is now gone and out of the way. Seem to have a few power poles and power lines. Those can easily be deleted as well. And now to get rid of some of this other data that could be caused by either power lines themselves or dust or material in the air, I'm going to run a filtration process using topography. What this does is it allows the software, Eyesight Studio, to look at the data at a 3-foot grid or whatever size that I choose. I'm going to go ahead and use 3 feet, and it keeps the point with the lowest elevation value. That's going to eliminate any sort of floating dust points out there and get us a much cleaner data set to start using for a triangulation. There's still a few on this scan. Just going to quickly delete those. And now we've got a nice cleaned up data set that we can use for creating a triangulation. So be sure that you have your entire scan selected, and I'm going to run a topographic triangulation on this. I'm putting in 10 feet for a maximum boundary edge length, which is the maximum distance between points the software is going to look to fill in the triangulation. I'm labeling this new, as this was the latest survey that I will be comparing to older data. Let's go ahead and look at that triangulation. I'm quickly going to change the color to something easier to see, make it bright green. And now you can see that we have a solid surface, and there's still these little spikes and areas of inconsistencies. And that is extremely easy to fix using the despike tool in iSight Studio, which allows the software to look for any extreme angular changes within the triangulation and get rid of those, recognizing them as an inconsistency. I'm also just going to delete this piece off here to the side because we don't need that. So now what we need is we need a base data set to compare this to. And what I have for that is I have this line work that was used. This is just lines drawn between points collected using a reflectorless total station. This is an extremely common method used. It has been used for a long time in stockpile instances like this, where it is not safe to get a surveyor on the stockpile itself. This is generally done by just measuring a few points around the base and then a point at the top. You can see that this implies a perfect conical shape, which using the more accurate iSight data is clearly not the case. But since it's what we have to compare it to, that is what we're going to do right now. I am going to make this maximum boundary edge length quite a bit larger. Because of the lack of data, we do need the software to be able to stretch that triangulation further than we normally would. So now that we've turned that data into a triangulation, we have two solid surfaces to compare against to get our accurate volumes. And I'm going to go ahead and overlap these two just to show the difference. And I'm going to change the translucency so you can really see the areas that would not have been considered using the older method. And it's extremely obvious how many tons that would have not been calculated and used in your calculations by just going with the older method. Go ahead and turn that back. Comparing these two to get an accurate volume is extremely simple. By querying the surface volume, we are prompted to put in a new surface, being the one that we created, this green one using the iSight data, and an original surface. And what this is going to do is this is going to calculate the amount of volume that is in between the two, so that it's been added over the course of the month. This gives us three numbers. It gives us the volume below the original, which is anything that's underneath this little cone right up here on top, because that area is actually quite a bit lower than what it was a month ago. And then the second number, everything above that original surface. And then it does the calculation for us to give us a total difference. And this is what would be used in the spreadsheet for the month. Now, if you don't have a base scan to compare these two, we could easily take that out of the mix. And if you know what the base elevation is, we can calculate it using that. By deleting our original surface and converting this calculation using a plane height, we can click anywhere on the surface and assign a base elevation to compare it to and calculate the volume using everything above that. In this instance, I wanted the 4485. I will quickly change that. And now we can run that calculation. And again, it does the same thing. It gives you the amount below, which is everything outside here that I didn't properly crop out, but we can ignore that number, and then the amount above. This is everything within this surface that is above that base elevation that we used. You can easily see how using iSight software just makes this process quick and painless, and looking at how accurate the data is and how much coverage we have with all of the data points, you can trust that these numbers are quite a bit more accurate and you're getting quality coverage of the entire area rather than just an overall view of the basic points using the old reflectorless total station. It's that easy, it's extremely quick, and if you know the mass density value, rather than using cubic yards, you can actually convert this to tons. And remember, if you're scanning with a reflectorless total station, you would need to manually measure all of these points all the way around the edge to try to get this sort of coverage. You cannot calculate volume on data that isn't there. My basic tip that I can suggest in any sort of scanning situation where you are looking for accurate volumes is proper coverage. If you remember when we started, we used 3 scans, and that's the best way to ensure that you get proper coverage on all sides. This can change depending on if you have multiple or a more complex shaped stockpile. But assuming you have proper coverage and you bring it into the iSight software, it's extremely quick and easy.
Great, thanks Clayton. Let's see if we have any questions. How long did it take to get these scans?
That's a great question. These scans were collected on a level 1, which is actually our lowest resolution setting, and it takes about 3 minutes per scan. Including setup time, all three of these together took about 20 minutes.
Okay. Is there any material that cannot be scanned?
There's not a material that cannot be scanned. However, there are materials that cannot be scanned at the same distance. Coal, being a much darker material, does not have the same reflective values as something like granite or a lighter rock color. So it can still be scanned, but not from the same distance. You won't see that 1,500 meter return. Probably about 1,000 meters is all the further you could scan coal from.
Okay. About how many setups would it take to scan a stockpile?
In an instance like this, where it's almost perfectly round, 3 is usually adequate coverage. Depending on the shape of the stockpile, and if there are alcoves that have been dug out using a loader or another piece of equipment, it could take more setups to get proper coverage, but 3 is a general good basis to start from.
Okay. Can you bring in boundaries via DXF or DWG or polyline to determine an outer boundary?
Yes, you can. iSight software easily imports DXF values, and those come in as a polygon, and we have a filtration process of filtering by polygon, which will actually cut the data down using that perimeter that can be imported as an AutoCAD file or anything like that.
Okay. What type of file imports will it accept for scanned data?
We can import DXF and DWG and any sort of triangulation file. We can also import point cloud data from almost any type of scanner on the market. I've yet to come across a file type that cannot be imported to Studio in a usable format.
Okay. Here's one. Can stockpiles be scanned from a vehicle?
Yes, they can. This one was actually scanned from a vehicle. We have a vehicle mount for our scanners, and this was scanned using the iSight truck and the 8800 scanner. And we just pulled up to areas where we knew we would get good coverage and scanned 3 spots from around the edges. And the nice thing about scanning from a vehicle is that it allows you quick mobilization to get in and out, and you don't have to set up a tripod, which in certain cases you cannot shut down production for too long a time, so that definitely saves you from stopping production for too long.
Sounds good. Here's another one. Can you do heads-up digitizing?
I'm not sure I exactly understand that question. I'm not sure what heads-up digitizing refers to. We can digitize polylines and polygons along point cloud data as well as the surface data. We can digitize contours and parallel cross sections, and then export those as a DXF or DWG or any other sort of acceptable format.
Okay, so maybe what we can do with that question is get back with him offline. I do have another one here. Can a tin be exported? T-I-N? Tin?
Yes, it can. A tin generally refers to the surface file, and that can be exported in several formats. We do export initially in an OOT, which works extremely well in Vulkan software, but that can also be exported as a DWG or a DXF. It is a little bit larger at that point, but extremely usable in AutoCAD as well as other mining softwares.
Okay, it looks like that's all the questions I see so far. Oh, here's one, sorry. Are all the points you selected and cropped permanently missing from the scans, or can they be recalled without reloading the original scans?
They can. It's actually a great question. Anytime you crop or filter data in iSight Studio, it doesn't delete it, it merely hides it from the view. And that can easily be brought back by filtering and showing all. All of that data is never lost. It's just not used during the calculations or building a surface. But it can be brought back with just the click of a button anytime you make a mistake or accidentally crop something.
Great. Here's another one. How large of a scan file can be imported? Number or points?
I have yet to come across a scan that cannot be imported into Studio. I've imported several scans that are upwards of 15 million points, and I've brought in about 10 of those at the same time. So I have yet to find the limit, but I'm sure it's out there somewhere.
That sounds like a challenge to all of you listeners. Let's see. It looks like that may be all the questions. I can wait a few more seconds to see if someone may be typing something in.
If any of our listeners do have further questions that involve a little bit more in-depth answer, you can call us here at Maptek, and I would be more than happy to go through the data one-on-one and talk on the phone, and we can go more in-depth and even discuss maybe a presentation or something like that if it's something that needs to be shown live and see the product in person.
Great. Thanks, Clayton. Here's one more that just came in. It says, ever use with mobile data?
It can be used with mobile data. We do not go collect mobile data due to there's an inherent lack of accuracy anytime you have a mobile scanner. There tends to be a little bit more play in the data itself. It almost has a fuzzy picture, but it can easily be imported and modeled using iSight software. Again, I have yet to come across a scanner or any sort of data that cannot be brought in and modeled.
Great. We have another question. How did you know to rotate that one green surface to its current position if you weren't familiar with the field view? Can you show the registering of scans one more time, please?
Absolutely. So what I'm going to do is I'm going to take these scans and I'm going to register them back to origin. And what the origin is initially when the scans are brought in, the scanner doesn't know where to put them unless we give it a coordinate system. So they all come in basically on top of each other in this kind of ugly mess right here. And then what I have is I have a CSV file that was collected using RTK GPS, and these points are named the same as what I named them in the field and in the scanner. So when I register by name, the software correlates this initial portion here where it says stockpile with one of these containers labeled stockpile, and then this S14 and S8 and S9, these right here, that's the first point which it's going to associate with the scanner location. These second ones being the backsite. So by registering by name, it gets them extremely close. But when we look at the number 14, we can see that it's not perfectly in the right spot. And I've got way too much stuff here. I'm going to do a quick crop so that we don't have all that outside data to look at. Makes it a little bit easier for our viewers. So the reason I knew to rotate this green scan is because if you zoom in and look at this, you can see that this conveyor, if that's easy to see for you guys out there, that conveyor is not sitting in the right location, whereas these two ones over here, they're almost right on top of each other, which is what you'd want to see. So by rotating that green scan, and if you're not sure which one it is, by going into Object Select Mode and clicking on it, it'll pick it for you. And then going into Rotate, and then about the origin of the scan. So I was basically just using that conveyor as a guideline, and I pretty much just guess at the numbers. If you pick 10, we can just rotate it a few times until we get it close, and it's sitting about in the right spot. And if you over-rotate, you can rotate back, forward being clockwise, backwards being counterclockwise. And then once it's close, it doesn't have to be perfect. As you can see, we've got 3 distinct conveyors, even though we all know that there's only one. So by selecting all of these and then using global matching surface features to fill in anything that was missed, and that's going to run that algorithm I was talking about earlier where it picks 5,000 random point pairs within all the data sets and looks for similarities, and then it will move those. What it's not doing is it's not moving them off of the surveyed location. So by honoring the survey location, we make sure that that is a consistent, that we don't deviate from that, and honor scanner leveling. Our scanner has an internal leveling compensator that will compensate up to 5 degrees if you're not level, which is extremely useful, especially when scanning from a truck. So by making sure that we're locked on both of those. It won't rotate about the z-axis. It'll only rotate about the z-axis and not change the northern and eastern coordinates. So to answer the question itself, how did I know to rotate it? I just saw the conveyor was out of place. I knew it needed to be rotated roughly 45 degrees to the left to line up, and just rotate it a little bit at a time until it matches close and let the software take over from there.
Great, thanks Clayton. I don't see any more questions yet. I can wait a few more seconds as I did before in case someone might be typing something in. I will tell you while we're waiting that we are going to have a booth at MineExpo next week, booth 6062. You're welcome to stop by the booth to see this in person. And in fact, Clayton will be doing a presentation next week on, let's see, Wednesday, September 26th at 1 o'clock. So stop by booth to learn more about that. That would be great. It looks like we do have another question. Are the small spikes generally caused by dust particles?
That's a great question. In this instance, yes. This is by a stockpile that's being fed by a conveyor, which does cause a certain amount of dust to be in the air. But those spikes can be caused by several things. In the wintertime, the laser can reflect off of snow particles that are in the air, and it can be caused by that as well, or just debris. I've actually seen a flock of birds fly through a scan, and you get a few points out of that. But dust can be caused by anything floating in the air. As the scanner is sending out so many data points, it picks up almost the even minutest details like dust and snow.
Great. Okay. Well, as Clayton mentioned, he is available to answer your questions if you have additional ones following this webinar. You can email info@maptek.com to contact him, or you can call the office. He will be at MineExpo next week as well. So on behalf of Clayton and the whole iSight team, I'd like to thank you for attending today's webinar. If you would like to see some more information about iSight, please visit maptek.com. And I also wanted to remind you that there is another webinar taking place on November 1st. That is the iSight 2013 preview. So you'll be able to see what's coming up next year. So with that, I think we can go ahead and conclude the webinar today. Thank you for attending.